let's get started. What are we talking about today?
All right, so we are on week 3 of streams, which I think this is going to be our last week of at least this little series we've been doing on streams. I'm sure we'll come back to streams at some point because they're lovely and we always make our circles around the ZIO ecosystem. But I think this will at least wrap up this series as we've been exploring the ZIO2 stream encoding and this idea of channels. And so in week 1, we really got into this idea of this channel as the underlying representation of a stream. And we saw how we could actually view sinks and pipelines as channels. And so we had this one data type to underlie everything we were doing in the streaming world. And then we actually saw how this was even more general and we could use it to describe ZIO itself as being a certain type of channel. And so our first week, I think, had a lot of interesting ideas and just understanding the essence of things, but was a little bit more abstract. And then in our second week, we got a little more concrete and we started implementing some of our own operators in terms of channels. And so like we did this, I think we did map operator, we did the scan operator, and we saw how we could use these channels to describe very high performance stream transformations that also gave us a lot of ability to customize exactly what we were doing, because this channel interface is in a way a very low level interface. At least some of these operators on it are, like this read with one, where we were able to quite explicitly say, read this and then do something. When you're ready, write it and then do something else and then read again. And if we wanted to, we could read twice and then write, or we could read and write twice. We had all this flexibility, so we could implement whatever we wanted here. And we also did this in essentially a single thread and without having to go through effects or concurrency when we didn't need it. So we got a lot of performance here. And so I think our goal for today is to get even more real world. And I think here we implemented some operators, which conceptually we could say, okay, yeah, that we can see why this might be a useful operator, but we maybe didn't do anything. And I think in particular, we had some questions about how to do encoding or decoding and how to deal with maybe I'm decoding something and I don't know yet based on what I've gotten of I may need to get more, or I may have too much and I need something is supposed to be the next thing that's decoded, or maybe I need to read something initially to know what I should be decoding. And so we wanted to work through some examples of that to build our intuition of using these channel operators and show how we can approach some of those problems. Does that make sense to everyone? And does anyone have any questions on that before we dive in?
Let's do the dive. Unless, wait, let me make sure. I think we're good.
I'm trusting you to man the Discord today.
Yeah, people can't talk. We have the Discord, and no, it's all good. There's a request for talking about fan out and fan in stuff as well. Maybe we could add that at the end, or.
Okay, yeah, if we can, we get to today, or maybe we will make it a 4th session. But yeah, I think we briefly, maybe in actually the first session, we hit on the fan out with the use of a broadcast operator. But yeah, we can talk about both of those. Okay, so today we're gonna talk about this like decoding example, and I think to make it accessible for us and to work from the ground up, we're gonna create our own little silly domain here. And maybe we'll be inspired by Kit here, and we'll be decoding a stream of sandwiches. These are ingredients. I don't know if we'll call on ingredients. Maybe we want actual types of sandwiches. What are some different types of sandwiches you might be interested in eating, Kit?
That's a hard question, and I was muted. Okay, there we go. I personally ordered something called a calypso today.
Oh, that's fancy.
Which is smoked turkey. That's a sandwich, I believe, unless you're punning on the word sandwich. That is not the traditional spelling of sandwich, but if we're trying to determine which sandwich.
No, I'm just being silly. Sometimes, as Kit knows, I'm like, why is my code not working? It's, I misspelled the word. Yeah, that's good. That's good. Okay, what are some other sandwiches?
Let me plug in some more from this. Let me find the right of my many windows. Okay, let's just go with this. Yes, I'm currently in Massachusetts, and I'm ordering from a local sandwich store in which they have some delicately named. What do we got? We've got Captain Chicken. So that's taking the seafaring nature of a captain.
Sure.
Certainly a Moby Dick in here. There's a Jaws. Let's go with that, which is roast beef, not shark meat. And let's see, a Porky's Nightmare. that sounds really dark, which is clearly a hand.
Really?
That's not great. There's a few. That's maybe I'll add
All
one
right.
more.
Yeah. All right.
Let's go.
Yeah. Do it.
There's one called for children. There's one called the boring sandwich. So that's great.
Places like on the nose. All right, obviously we're doing a little bit of a silly example here with the sandwiches, but we can imagine these are our domain objects, and we can see they're like these typed scalar values, and we're using our data modeling best practices of, we've got this sealed trait, or in scale 3 we would do the enum, it gets kind of sealed for us, and these are objects, and maybe if these had some other info associated with them, they'd be case classes, but right now they're just case objects. And so we can imagine that we want to have this, let's call it sandwich mapping, maybe sandwich mapping. And this is basically going to be a mapping between what we could think of as like the encoded values and these decoded values, right? So these are just going to be the strings that maybe these are going to come over the wire to us in a sandwich wire that sandwich stream we're going to be consuming. And we're going to want to convert these into these typed values. And we can see that these have like different lengths associated with them. So we're not just going to be able to say, take 4 characters and map them to this. We're going to have to do a little bit more of, we'd say this is like variable length here. So this is trying to get at one of the patterns that I think we got asked about the other week. Another pattern I think is pretty common is the stream in like the beginning has a header and says, okay, after this, like everything is going to be the size. Maybe we can look at that as well. But I think this is a fun one, and we'll hopefully have enough to it to keep us working a little while. Okay, so we've got our sandwiches. We've got our mapping between kind of our encoded and our decoded values. And then Kit has created this chunk that's basically just this chunk of characters that if we decode them, hopefully we can eventually get back to having these sandwiches. But maybe if just to demonstrate it for ourselves right now, if we just print this out, oops, I was demoing something for someone else about thread pools. So let me get back here. Our stuff. Okay, so we can see that the stuff's in here, but right now it's just this like big stream of characters. And we would like to make it something that is nicely typed so we can do operations on it. Maybe we want to add a condiment to like all these or something. So how can we do that? First, let's take this. That's interesting, but no. So first, let's maybe think about, we want to go into the streaming world. So we're going to have this encoded, which is stream. And we can just do zstream.from chunk encoded sandwiches. And one of the things we are going to want to have here is the property that our decoding should work regardless of the chunk structure of this stream. So if the stream is like a chunk of C and then a chunk of A, that should work, or if it's a chunk of CA, that should work too. So we'll come to that when we do our implementation. And so whenever we want to, so maybe let's just sketch out what we need here. So what we want is we want this stream of sandwiches. And what we eventually want to do then is we want to take this and we want to collect it and we want to debug it. And we hopefully want to get a nice list of basically these typed values here. So whenever we need to go from one stream to another, that means we need one of those middle parts. And so we can remember the middle part is a pipeline here. So we could say val sandwich, let's see how so bad it's spelling this, sandwich decoding pipeline. And this is going to be a pipeline that if we remember our type parameters, it doesn't require an environment. It can't fail. It consumes characters and it outputs sandwiches, which would be, if you could actually eat those sandwiches, would be quite lovely if it was around lunchtime. And let's see, what do we got here?
Something with my eat method, yes. Sorry, don't get autocomplete, so I'm just slowly guessing, but there we go.
It's fine.
Was it just tap then?
It's just tap, yeah, because you can't really tap. It wouldn't do anything if it didn't do an effect. Okay, so yeah, we basically got the same thing, but Kit has now added a eat method here, which will tell something about our sandwiches. So lovely. Okay, and now if we just have this, even without doing this implementation, if we've got one thing and we've got a pipeline that changes these things, then we can just use that encoded sandwich stream. We can just use that triple error operator to do that transformation. Or, oops, I think maybe Kit was working on making this prettier. There we go.
Did I play something? There we go. Cool.
No. I think I just got you halfway through keystrokes.
Gotcha.
So I can just use this triple arrow operator to send all the inputs from here through this pipeline. And if I don't like the symbolic operators, I can also do this via instead for this. Those are the same thing, but I think Kit kind of likes the symbolic operators. So since we're trying to get him his sandwiches, we will stick with the triple A.
Feels like a pipeline. If there's one operator, it
Yeah,
looks right.
no, it is really nice, and especially if we have some sync. And one thing we could do here is we don't even need this to be run collect. That could be another sync, but maybe we'll do that at the end, just to demonstrate that.
Yeah.
Okay, but so far we haven't really actually done anything to solve our problem, but we've just architected things and gotten it down to, okay, we just need to implement this pipeline. And so how do we do that? The way I like to start here a little bit is we know from our discussion before that all of these types, the pipelines and the syncs, they're just wrappers around a channel. So what we're going to want to do is we're going to want to implement at least if we're doing this like low level operators, we're going to want to start with a channel and just wrap it up in a pipeline. So we could do something of maybe I'll call this a reader. And so this is going to be a channel that doesn't require any environment. If we remember our like definitions of the pipeline, which we had up here, maybe we can just copy this down here so we can remind ourselves. So it doesn't consume errors, it doesn't handle errors, and it's going to take a chunk of its inputs. So it's going to take a chunk of characters as inputs. It's not going to care about its done value, but it will accept one. This particular one will fail with an error. It's going to output a chunk of sandwiches. I hope you're hungry. And it's going to return, eventually finish with some value in it. And if I had that, then I can just do Z pipeline from channel here. So I'm just making my thing simpler and simpler problems. So now we've got, okay, how do we want to implement this channel that's going to go from characters to sandwiches? And I think conceptually, like if we just describe it in plain English to ourselves, I think what we're going to want to do roughly is we're going to want to say, read some input. Then we're going to want to decode as many sandwiches as we can from that input. And we're maybe going to get some leftover input. So we could imagine if maybe the first chunk is like Calypso pork. And so we would parse this first part and we get Calypso, but we'd have pork left over. And so we had that like leftover input. And then we would emit the sandwiches we decoded. And then we would read more input and add it to the leftovers and repeat. Does that make sense to everyone? Not necessarily how we're going to do it in code, but as just like what we would need to do if we were like sketching out on a whiteboard what we need this thing to do for us?
Makes sense to me. Yeah, and Naveed also is impressed with your ability to remember all the Z channel parameters, which is a bit of a feat. Maybe when we're done with this, we could see if are some higher level operators that would allow us to do a similar thing. I'm not sure. Maybe this is just too specific and low level. That could be interesting. But yeah, but let's, it seems like everyone, I see some thumbs.
Okay. Cool. So we've got this basic like pattern of we're going to want to read and write and do something again. And so the low level operator to help us do this is this z channel.readWith. And if you remember, we worked with that a little bit before. I'm going to take advantage of at least part of what Copilot does here. But this gives us this, oops, extra one here. This gives us this, takes 3 different functions. And so it basically says, if you get some more input from your upstream, what do you want to do with it? If you get an error from your upstream, what do you want to do with it? And if you get a done value from your upstream, what do you want to do with it? And one thing to note here is if I do nothing instead of Z nothing here, I'm going to get a weird compiler error. So this is like where this Z nothing data type comes in handy. I'm going to use that, and this will all work fine without me having to manually specify everything. And then, at least for a lot of these stream transformation operators, these two end up being pretty straightforward. Of if our upstream fails, then we just propagate that failure. And in this case, it doesn't really even matter because we're saying our upstream can't fail. And if our upstream is done, then we're done. And those are going to be quite easy. And then this one, if we get some input, so here we're going to want to do something with it. And this is where we've got a little bit of work to do. So you can see in a way, still, we haven't done any like actual logic of parsing, but we're like making our problem smaller and smaller. So here, I think I'm going to create a little bit of a helper method for us here. And maybe we'll call this something like process buffer. And so this is going to take this buffer. That's a chunk of characters. And it's also going to take some new input that in this world is also a chunk of characters. And it's going to output some leftovers and a chunk of sandwiches. Oops, thank you.
Cool.
And so conceptually, what this is going to do is we're just going to take the buffer, take the input, put it together, say, okay, here's everything we've gotten. And then we're going to process as much of it as we can into sandwiches. And they're going to go into this chunk. And anything that we weren't able to process yet, that the next sandwich that's going to come to us from the next time we pull from the upstream is going to go into here.
Just to make that concrete really quickly, maybe with a little code or comment illustration. If we get some, so we want one of our sandwiches is called like the boring, another one's called the jaws. So if we get the letters in our first chunk that comes in, if it's the characters of jaws and then BO or something, we would ideally like to omit from this as our buffer BO, because BO could not be parsed into a sandwich. So that would be the sort of the leftovers, the buffer. And we also want to return a chunk of our sandwich .jaws as our actual sandwich. So next time when we read, we might get something like ring, boring, and then the beginnings of some other sandwich. And then that second time, we're going to use the previous leftovers to concatenate it with our new input. So we'll parse out 3 boring sandwiches. You get the idea. Boring, one more, not jaws, boring. And then we'll be left over now, this time with CA that we can use in the next iteration, probably, hopefully, to parse out that Calypso sandwich. So yeah, hopefully that helps illustrate what we want there.
Yeah, that's a fantastic illustration.
Oh, what if upstream is done and we have leftovers? Are they lost? I think we'd have to be, or we can handle it in some intelligent way based on the protocol or the buffer button. And for this sandwich protocol that we're coming up with, the sandwich format, I think we'd need the whole sandwich string. So if the upstream closes, then clearly there's some sort of issue and we can't. Maybe we can infer the final sandwich, but it's up to us.
Yeah, so yeah, it's up to us. And we'll see in a sec kind of how we like where we have this buffer, but we can do what we want with it. So maybe we should print a warning in that case. I think it's just, yeah. Okay, so the other thing that I think is apparent from all these descriptions is we need to maintain some state here. And whenever we need to maintain some state when we're doing this kind of reading pattern, a really nice way to do it is to just make that part of the parameter here. So here I could just say, I'm going to take a buffer that's a chunk of characters. And then we could start with the empty chunk down here. Oops, one more, yeah.
Lovely.
And now that'll give us some way to implement this thing here. Is we could say like, warning, sandwich fragment.
Sandwich fragment. And then probably do like is there a when on channel, or we could just use the when on ZIO?
Yep. Perfect.
Is there a when on channel? Well, I don't have autocomplete, but anywho.
Okay. So now we've just got this part here. And the cool thing is if we have this process buffer, this is actually pretty simple, because what I can say is I can say val leftovers sandwiches is equal to process buffer input. And then I can say I want to write all of the sandwiches. And then I want to run this whole thing again with the leftovers. And let's see, I think what did we, oh, we just, let's see.
Is that happy? Oh, no.
Oh, I think I just need a Z nothing here.
Or is it
There we go.
nothing?
Yeah, it's nothing.
Z goggles. Perfect. Okay, cool.
And so the kind of cool thing about this now is like this, I think, is relatively straightforward, actually, at least once we're like into this like channel and like reading world. There's no complex logic going on here. In a way, we still haven't done the actual hard part. We've deferred it to this process buffer thing. But the neat thing now is that this process buffer doesn't actually know anything about like streams or channels or anything. Now it's just this like character like decoding thing that is you might get in like a coding interview or something, but it doesn't, you can replace these with lists, right? This is just like a Scala standard library thing or just a programming thing in general that doesn't involve anything fancy here. So we'll go through and implement this, but that's a nice, I think, thing about this pattern. Okay, let's try to do this. And the other cool thing about this is you'll notice here, this is just like a pure method. It's a private method. It's going to do some stuff internally. It's great to have this like higher level code and be very functional. Within this block, it's also fine to do very low level things, either just because it makes it easier for us or because it's more performant here. So I think I'm going to take advantage of that here. And I think I'm going to just use some mutable state here. So I think I'm going to start by saying I have this combined thing that's the result of taking the buffer and the input together, and it's just basically, okay, here's everything I've got so far that I haven't written out. And then I'm going to give myself an iterator on that, so I can do my low level fun stuff. And I'm also going to give myself a builder.
A chunk builder of sandwich.
Chunk builder of sandwich.
I believe in the sandwich making industry, at least at Subway, this would be referred to as a sandwich artist. So we should call
sounds good. Yeah, sounds good. And then I think it's going to be helpful to have some concept we might call the candidate, or maybe we'll come up with a more sandwich domain appropriate name for this.
I think candidate works.
This will basically be like the thing that we're building up that we're going to try to decode into a sandwich or make into a sandwich. And so I think one, if I'm embracing this like low level world, I think I could just say iterator has next, and I'll just, oops. Sometimes I feel like, I mean, compile is good, but it like steals my thunder a little bit. So we're going to do some stuff with the iterator while it has next. And then at the very end, we are supposed to return the leftovers. And the leftovers are basically going to be the last candidate. So I think we can just do chunk from iterable candidate, and then the result of the sandwich artist. And so now our problem is just in this while loop, we've got to get all the sandwiches into the sandwich artist, and we've got to have a candidate that is left over with whatever we haven't used yet. And so I think what we can do here is the iterator has next. We can say this character is equal to iterator.next. Then we could say candidate is equal to the candidate plus this character. And then we could say sandwich mapping dot get candidate. And we can match on this. And we have two cases. We have the case where we get the, I really can't be trusted to spell the sandwich. Make sure this compiles. Okay. Okay. So if this candidate can be decoded into a sandwich, then we should add it to the sandwich artist. And we should reset the candidate back to being empty because we've now consumed those inputs. So we want to remove those from our little internal buffer here. Oh, and I think this is supposed to be plus equals.
And maybe for clarity, I'll undo my.
It was fun, but yes, the builder might be. Okay. And so none means this thing doesn't exist, which means that we need to get more input to get something that is a valid sandwich. And so I think here we really don't need to do anything right now because we'll just loop again and we'll get another item. So I think now this will do everything we need it to do.
I guess maybe,
yeah.
Oh, never mind. I want to add the car before we check for candidates. Never mind. Never mind.
No, this is definitely where we've done the high level. Now we're like ready to put everything together, and we'll see if things work or blow up. But I'm sorry, go ahead.
No, that looks good to me. I guess one since I have taken the start speaking. Would this be slightly, marginally, almost pointlessly more performant to combine iterators?
Yes.
Okay.
Yep.
Why not?
There's probably other things we could do. Like we can see we're tearing down and rebuilding these chunks. Maybe we could just pass around an iterator. We wanted to get even more efficient with our sandwich construction. We probably could. But okay, so let's actually try running this now. Oops. Close the thing. Okay, so I'm going to do run. Get my decoding example. And look at that. So first, before we even get to Kit's fanciness, we can see that we decoded from this Calypso, Porky's Nightmare, boring, oops, Jaws and Jaws. And obviously now, like we've printed out these and using the two strings from these case objects, so they look like strings again, but these were all these typed objects here. So we successfully went from having this like set of strings or stream of strings into this stream of these type domain objects. And so that could apply to your like bytes to JSON or bytes to domain values or what have you. And then you can see that because they were these type values, we also were able to do other operators on them. So like tap this and do this eat thing. And I guess if we wanted to, we could do fancier things. We could say the boring is not delicious. The boring is like boring and the other ones are delicious, but we can work with them because they're now these actual type values in our domain here. And the other cool thing about this is that this is going to be actually quite a high performance implementation, maybe aside from our little games with iterators here, because all of these channel operators, at least this channel here, you'll notice that except for this one ZIO workflow, which we only potentially do once at the very end of the whole stream, nothing in here is actually using ZIO. And one of the big reasons for this channel encoding in ZIO2 is we wanted to avoid having to go through ZIO when we didn't really need it. So we have some streams where it's really important to have effects and resources where we're opening a file, we need to make sure to close it, or we're running streams concurrently. But we also have some parts of these streams where we don't really need that, where we're just like processing data. And going through all that ZIO machinery actually adds unnecessary overhead. So you can see here, like other than maintaining this little bit of internal state of this buffer, all we're doing is like read, write, process a little bit in the middle, read, write. And Z channel is actually able to take advantage of that. So this whole thing is never going to go through a ZIO effect. It's never going to fork fibers. It's never going to do any of that except where it needs to, which at least in this case is this like very trivial thing that will at most happen once at the end of the stream. So it's a really nice thing about the channel encoding here. Let's look at one other thing, which is we talked about this idea of, you could call, I guess, chunk equivalence maybe, which is we should expect that we should get the same result regardless of the chunk structure of this thing. So like right now, if we go back to our little stream here, this is a Z stream from a single chunk. And so if we wanted to, we could do, I think I have this new, this thing, chunks with blank dot, so I believe, let's see if this works, will show us the chunk structure. Oops, I ran the wrong one, sorry. Okay, so you can see that right now we're working with this like one giant chunk. So right now, if we think about how this is actually working, we're reading this one chunk. I mean, objectively, it's not that giant, but for this example, it's giant. It has all the data. We're processing it all with this process buffer, and then we're writing all these things. So it's working, but you could say maybe that's not like really stress testing our logic here, because we're not like reading these smaller chunks or like malformed chunks or things like that. So what we can do here is let me take this thing and let me like rechunk it into maybe chunks, start with chunks of size 1. And let's see what happens here. And let's test ourselves, because maybe we messed something up, but we'll see. And so look at that. So now we can see each of these is one individual chunk, just one chunk of one character. And we've still successfully decoded all of our sandwiches. I can do the same thing. I can change the chunk size to 2. And I still got all my sandwiches. I can change the chunk size to 3. And I still get all my sandwiches. So that's one of the properties we want with these stream operators, is we don't want to be relying on a particular chunk structure, because maybe it's going to come in different chunk sizes. But we can see that just by using this read with operator, and then we had all of our non-channel lower level logic in just this process buffer, we did this, and we did it in a way where it's totally agnostic to that. So whatever the chunk structure is, as long as we've got the right data here, we're going to do this. And maybe we can try to do that last thing that we were talking about. So what if we have, see if it handles this correctly. So now we've got this partial thing at the end. And let's try running that.
Yay, warning.
Sandwich fragment, Porky's lost. Hunger may ensue. Oh no. Yeah.
Any remaining questions? Otherwise, I think we're good to wrap it up. I need to eat my actual sandwich.
The actual sandwich? All right.
Maybe then
Well,
I can
awesome.
write it. Okay. Take care, everybody.
Thanks so much, everyone.
Bye, all.
Take care.